Behold, the beast. That is the Wheatstone Bridge. Just kidding, it's not that bad. So this circuit is called a Wheatstone Bridge, and it's used to determine the value of an unknown resistor X by comparing it to three other resistors M, N, and P, whose resistances can be varied. Wow, can't talk. Okay, so these resistors are varied until the current in my galvanometer reads 0. And that's when the bridge is said to be balanced. So problem 74 wants us to show that under this condition, the unknown resistance is given by X equals MP over N. So if the current through here is 0, so I equals 0 through our galvanometer. So if the current through here is equal to 0, that's the same as that wire not existing, period. Cool? So no current is going from over here to over here, which means I can treat this circuit like so. So if I drew my little bridge here, it would be identical to this one. But there's no current going through here, so it's as if that little bridge is not there. Cool? So that means N and M are in series. So their resistance is just N plus M. P and X are in series. So their resistance is just P plus X. These two branches are in parallel with each other, which means the voltage Nm is equal to the voltage Px. Okay? And that's equal to our EMF. So V equals IR. So this is I and M times R. And that's equal to I Px times R. Okay? Now, we also know, because there's this little bridge here, the voltage along this whole little blob, let me color it, has to be the same. Otherwise, there would be current flowing through here. So there's no current here, so we can treat it as it's not there. But there's no current here, which also tells us that the voltage here is equal to the voltage here. Which means the voltage drop across just N is equal to the voltage drop across just P, which is I and M times N equal to I Px times P. All right? So now I and M is equal to I Px P over N. So I can take that and stuff that in there. So I have I Px P over N times N plus M is equal to I Px times P plus X. So my IPXs cancel. So the current and the voltage through this circuit does not matter. Doesn't matter. So now I can solve for x. So x equals P over N plus M minus P. So if I simplify this, I get P times N over N. It's just P. P times M over N. P, M over N. And then minus P. These cancel out. So X is P, M over N. Huzzah! Alright, so part B is just stuffing in numbers. So part B, if galvanometer G shows 0 deflection when M is equal to 850 ohms, N is 15 ohms, and P is 33.48, what is the unknown resistance X? So X was MP over N. So M was 850, P was 33.48, and N was 15. So if we plug that in, we get 1897 ohms. And that's it.